So with that said, we have an interesting collaborative presentation tonight by two different ends of the Kinect equation. They are Stewart Tansley from Microsoft Research and Arnold Blinn from Microsoft Studios. They represent respectively the different ends of the food chain of the Kinect as a device in terms of its development and research around natural user interfaces, and also the development of new applications and forms of entertainment and engagement that use this revolutionary device. Microsoft is the main sponsor of Art and Code through a grant delivered through the Computational Thinking Center at Carnegie Mellon, which has been promoting computational thinking in all different manners within culture and within computing. So Microsoft has very generously made this conference possible, and also Microsoft has loaned Kinect so that you guys can learn how to do some Kinect programming today yourselves and also tomorrow. And here they are to talk about basically a wide-ranging history of the Kinect, its present deployment in culture, and some futures that involve this kind of natural user interface. Thanks so much, and please welcome Stewart Tansley and Arnold Blinn.
I'll introduce myself first. I'm Arnold Blinn. As Golan said, I work in Microsoft Studios. We're the division of Microsoft that produces what you guys know as games for the Xbox and for the PC. And in Microsoft Studios, I'm the development manager for 3 of our different studios. One of them is Good Science. We're the studio that did the product called Kinect Adventures. That's the game that is bundled with the Kinect sensor. We also did a product called, a series of products and experiences called Kinect Fun Labs, which I'm going to talk a little bit about toward the end of the presentation, and also run some of the development for a service called Kinect Share, which is a social service that allows the sharing of user-generated content from Kinect experiences. Our studios are part of a group of studios within Microsoft Studios that focuses on really dog-fooding the next generation gaming stuff from the platform team. So we were really the first studio to get our hands on Kinect. We built a lot of the underlying stuff that drove what went into the platform of Kinect to make the skeletal tracking and all the other features work the way they needed to work. As a secondary note, I also happen to be a Carnegie Mellon alum, and I'm a member of the adjunct faculty of the Entertainment and Technology Center here at Microsoft. So I'm pretty involved with here at Carnegie Mellon. So I'm pretty involved with the school still, doing kind of, media and entertainment technology experiences. I'll let Stewart introduce himself.
Hi everyone, so I'm Stewart Tansley. It's my pleasure to present with my co-presenter here, Arnold. I think Golan put it well, the sort of two ends of the spectrum, or two sides of the coin, all sorts of metaphors you can think about. So I'm from Microsoft Research. There I'm newly Director for Natural User Interface Research in Microsoft Research Connections. Microsoft Research Connections is a bridging group between Microsoft Research researchers internal to Microsoft Research and people in the academic community. So for those that don't know so much about Microsoft Research, we're one of the really few remaining pure research labs in the industrial world. Think of us as a giant computer science department. There's 850 PhD researchers around the world, and we're all doing computer science or applied computer science. In Research Connections, we're bridging those folks with people, many of which are like yourself. I have 2 roles like Arnold, and my other role it has been a privilege to work with the Xbox team this year. And about 18 months ago, it's August 2010, I started my efforts to help get the Kinect SDK out to this community and beyond. We also are very interested to see it commercialized, but that's not right for Microsoft Research to do, and we'll have to say more about the commercial side of the SDK in due course. But as my secondary role, as the acting product manager, it's a kind of marketing role in a way, a communications role, a role that helps put together what the SDK is all about so it's most useful for you guys.
So we're going to tag team a little in this presentation. Thought we'd start with a little bit of a history thing going on here. Why did we do Kinect? Well, to understand why Microsoft did this thing called Kinect, I'm going to go back in time and talk a little bit about the history of gaming consoles. This is kind of a fun deck that one of my colleagues gave me that has a bunch of different historical gaming consoles in here. I'd be interested to hear, as I show some of these consoles and experiences, if people remember these or if they had them. That would be kind of fun. So, you know, in the early days, I'm going to go very fast though too. So in the early days, there were a lot of consoles. This was one of the first ones I had. This was the game Pong by Atari. Did anyone have Pong? Yeah, a few people had Pong. Massively revolutionary when it came out. And of course, everyone who raised their hand is really showing their age here. But, you know, of note here is that the thing played one game. It hooked up to your PC, or to your TV, and it played one game. And the controller is of particular note here, right? Look at the simplicity of this controller right here. All it was a little wheel, and it moved the dial up and down, or the paddle up and down on the screen. And you know, based on the success of this product, Atari came out with another generation of this thing. It had 4 different games instead of 1 game built in. But then on that success, they came out with, you know, what I would say, yeah, the best console ever, right? I mean, this thing was totally radical when it came out. I probably spent, you know, hundreds of hours playing this thing over the years. But the controller got a little bit more advanced. They still had the paddle controllers because they wanted to be able to play the Pong style games. But they introduced this little joystick controller thingamabob. And you know, it was an analog stick. It had a button, so you could play a whole nother class of games with it. And you know, based on the success of the Atari, other companies started coming out with similar consoles, and the controllers all started to evolve a little. This had a numeric pad on it, the old ColecoVision. Anybody have that one? I had that one. Yeah, a few more people had that one.
These guys have every single one.
Yeah, we'll see if he's had every single one. Now this one was pretty popular. This was, you know, one of the early Nintendo machines and the introduction of our buddy Mario. And now the controller is starting to evolve with a little bit of a D-pad and a couple of buttons. So things are starting to look a little more modern here. Sega came out with a system. Sega had systems for a few years there, of course. And this one, you know, the controller looks similar to the Nintendo, but now we've got like this funky peripheral, a gun. And these guns they worked on light, and they were kind of fun, and you could shoot things on the screen with them, usually ducks or criminals or something. You know, and NEC came out with a different system, and you know, this controller looked pretty similar. And Sega came out with another generation of their system, and some of these systems weren't as popular as others, but you know, we certainly remember these things over the years. The controller on this one is a little bit clunky. It had a nice joystick on it and a bunch of buttons, more of a, you know, Street Fighter style controller on that thing. Nintendo came out with further generations. Their controller's evolving a little now. It had 4 buttons instead of 2 buttons. The Jaguar, very hyped product when it came out, right? But look at the controller on this beast, right? This had like 16 buttons on it, and powerful system that never really took off for a variety of reasons. You know, Sega came out with an extension pack. It's interesting to see that because extending the life of their first gen system. The Nintendo 64, some of the younger people in the audience probably are starting to say, oh yeah, I remember that thing. But the controller now is starting to get a shape that's a little bit more familiar to modern systems ergonomically. I think the companies like Nintendo were starting to think about the ergonomics of the controller a little. More buttons were added to their basic controller, and it's starting to look very contemporary. The Dreamcast, another console that had moderate success, but this controller is noteworthy because it had a little bit of a screen in it. That was interesting as well, and we're starting to see that make a renaissance. Sony's first foray into the market here, the PlayStation, PS1. the PS2, the Nintendo GameCube, very, very popular again with the Nintendo demographic. Again, the controller starting to have multiple joysticks and a D-pad on it. One of my favorites, of course, the Xbox entered the market, had pretty good success with games like Halo, but again, our first entry into the market. The controller, of course, now looks very familiar to modern controllers. Sony came out with, different versions of their PlayStation. This was an interesting machine. Does anybody remember this one? Yeah, this one I actually hadn't heard of when I first got this deck to me. What was interesting about this Zavix machine was there were two things that were interesting in it. This one actually had a camera-based sensor. It was really the first gaming console that encouraged people to get up off the sofa and play. It actually had a sensor and did some level of tracking. The other thing that was kind of funky about this console was that the CPU and all the compute power was in the cartridge. It wasn't in the game console itself, which is kind of an interesting model. But the console obviously wasn't a very big success because none of us have even heard of it. Of course, then we have the Xbox 360, gratuitous cheer from the audience. We've got, of course, a controller we're really familiar with now, the Sony PlayStation 3, gratuitous boo from the audience. Yeah, thank you. And then, of course, the Nintendo Wii. And yeah, the Nintendo Wii, it's an interesting product. I have one, and a little bit of reflectiveness on this product that I think is interesting. When the Nintendo Wii was introduced at E3, a lot of people in the industry really dismissed it. They said this thing's underpowered, it's got this funky wand controller, who wants this thing? And there was a lot of skepticism about it. And when the thing came out, it really surprised a lot of people in the industry and how successful it was. And the reason it was successful, it's a double-edged sword, if you think about it a little bit. On the one hand, it's successful because a lot of people who weren't traditional game console consumers bought this thing. My in-laws, my mother and father-in-law bought one. It's like, I don't think they owned a console their whole life for their family. They played the bowling game. But that's the other side of the sword, is they played the bowling game. And that was it. They never bought any additional games. It was never, so as a commercial success for Nintendo, it's had mixed results. They sold a lot of consoles, but they haven't had a high, what we call in the industry, attach rate to the console. But it did show us something. It showed us that an accessible, less complicated controller, there's something there. So, we looked at this and said, with the success of the Nintendo, and said, what are we going to do? Because the state of the art of the controller, I mean, look at this thing. It's crazy, all these different connections and D-pads, and it takes, 100 hours to learn how to play a game, to the point where I play games and I just get frustrated after 10 minutes by the time they tell me the 15th sequence of buttons I have to know to play the game. So totally unapproachable gameplay with these complicated controllers. So, we thought about it and said, gee, maybe we ought to do something like the Wii. And we had prototypes working that were, simpler, more motion-oriented controllers. But we very quickly realized that, we wanted to go further. And we started having some discussions with some folks over in Microsoft Research about some technology that they had. That was the early precursors of Kinect, and realized this would be really a way to leapfrog that paradigm shift and make gaming controlling even more accessible by, instead of having a controller be a controller, have you be the controller. And that's really how we got to where we're at, in that we decided very consciously to make a big bet on this thing called Kinect, and worked with research to solve that problem. And I'll let Stewart take over and talk a little bit about some of the challenges we faced in doing that.
Thank you, Arnold. I'll be good with this, I think. So what does that mean? So Xbox come to Microsoft Research with this vision for a controllerless experience. Can we make the consumer, the player, the game player, the actual controller themselves? And if you're thinking about it from an engineering point of view, what does this mean? So at a very high level, if many of you are familiar with computer vision, you're doing this, you're practitioners. You need to find the people in the scene while ignoring the background, a familiar problem. You need to find their limbs and joints because you're trying to eventually get to gestures, so you need to segment the image. Which person is which? Games are often more fun with more than one person, something that Xbox has particularly driven, the social experience of gaming. We're trying to get to gestures, so how do you actually determine gestures from this segmented scene? And then map the gestures to meaning and commands. It would also, for a full, complete gaming experience, be good to recognize faces and see these people as individuals. Be good to recognize voices and commands, because if it's just gesturing, well, maybe there's a bit more to it in an entertainment experience. People speak naturally, we're talking, we're shouting, enjoying the game. Can I command in that environment too? And I need to do this at a consumer level. This is not something that could be really expensive, cost thousands of dollars. Xbox is for everybody. We need to make this at a reasonable cost at consumer levels so we can sell millions of units. By the way, we also need to play the game. The Xbox, which we want to run this on, as well as doing all this high-end computer vision, which just a few years ago would have taken the entire power of the Xbox, but the Xbox needs to be playing the game and running all the graphics, the AI in the game. So a little bit of magic was required. Now magic has become a sort of trendy phrase in software, but I have to say that in Kinect, I think the term is legitimate. We're standing on the shoulders of giants. Some are giants, researchers in Microsoft Research, but have often worked with academics over the years. There's been decades of computer vision research here between industry and academia in computer vision, and audio as well, because remember, it's important that audio is part of the experience. Xbox have brilliant people too. It's not all the sort of geniuses in Microsoft are not just in research. They're spread across the company. The state of the art, though, in human body tracking in 2007, when we first got together with Xbox, was that you could track people with a wide range of motion, but only with limited agility and not in real time. And we still see some of those conditions even today. We're starting to see real-time vision processing with human beings, not least thanks to the work with Kinect. But at that time, it was all batch processing. So the secret here, contemporary technology, my own field in fact, while I'm playing at being marketing for the Kinect SDK, I'm really an AI person. My background is in expert systems, knowledge-based systems, not so much in probability, which this artificial intelligence is involved, but my PhD is I can relate to this work, hence my involvement. So machine learning is the way to do it, but what does that mean at a high level? Well, I need to effectively evaluate trillions of potential body configurations, the human body, not just one model ideal human being, but children, old people, you, me, women, men. You need to evaluate trillions of potential body configurations of, at that time, 32 skeletal segments. You need to do that every video frame because this is a real-time experience. You can't be doing this over a slow period. It's not in slow motion. I need to be doing this, therefore, 30 frames a second in the US at 60 hertz. And I need to be doing that on less than 10% of the CPU because the Xbox needs to be playing the game and showing the graphics.
And just keep in mind that it's a CPU from 2006. It's not a contemporary CPU. It's the Xbox 360's CPU.
So another way to put this is it's not just real time. We couldn't even in 2007 do real time, remember, but not just real time, but 10 times real time. It's pretty crazy. I think software magic is deserved here. So you're familiar with the cameras, and we won't go through that today. You know that the main principles of Kinect. This conference has been pervasive with that. It's been awesome to see and humbling. The depth map is key. We can segment from the depth map. The skeleton is where we're trying to get to in the graphics and vision pipeline for Kinect. So here there are the 20 body segments that you're so familiar with today. So that's what we're trying to extract so that we can map them to gestures. The vision algorithm has now been published. There are clearly a few optimizations and proprietary parts of that we don't want to just share with the world. It is a commercial product, but the core algorithm is right there in the papers. I won't go through all this detail for this community today, not least because you're probably familiar, but let me just tease out the key points. So remember, we're looking just at a single depth image with this algorithm. It's not looking at a temporal sequencing. It's not tracking in time. It just looks at a single frame, depth only, ignores the RGB. We have the RGB in the sensor for other purposes. It's just a single depth image. And it uses an object recognition approach, and this was the key insight at Microsoft Research Cambridge in England. I happen to be English. I'm actually based in Redmond, just in case anybody's confused. I'm in Seattle, originally English, but the Cambridge researchers were the primary vision researchers, although other researchers around the world were involved. And they had, over a number of years, and taken an object recognition approach to try to identify and label semantic recognition of what was going on in a video frame or a static picture. And they boiled it down. Their algorithm used a per pixel classification problem. So this is where, again, the magic comes in. Not only are you just looking at the depth image, you're looking at a single image at a time. You're also just looking at a pixel classification problem. And the way it works, essentially, if you read the paper or get the high-level points from this slide, is that I can get a probability for each pixel being part of the body. In practice, you need, because it's machine learning, you need a lot of training data to make this work, to have it generalized for the mass consumer market, for everybody, to make this work, not just for an ideal human being or just Microsoft employees or the people in the lab working on Xbox. Have this work for everybody, you need generalization. To get that generalization, you need a very large training set. And so we actually went out to Hollywood, worked with the Hollywood a type of motion capture type community, and built up that training set. The processing of those millions of images was non-trivial in itself, so we had to use very high-end data processing. To cut a long story short, go read the paper. It won Best Paper Award at CVPR, the major computer vision conference, in 2011. If you just choose your favorite search engine, I know a good one. Check out the Best Paper Award for CVPR 2011. It's not just about vision. We really do believe that natural user interface, NUI, is more than just this vision. The vision is excellent, it's awesome, it's part of the solution for sure. You can solve interesting problems and come up with creative solutions just doing vision. That's agreed. But we're really passionate about the audio side of this, and we put a sophisticated audio system into Kinect. So there's a 4-element microphone array and a lot of processing that goes behind that. Let me give you a quick demo. So just one of the features in the high-order processing for audio on Kinect is echo cancellation over multi-channels. So this is what a microphone might hear for just a raw data stream. Now if we can do some echo cancellation past that processing, this is what you might hear.
Multi-channel echo cancellation, extracting my voice from the game sounds.
That gives a much cleaner signal for the speech processor to now do some speech recognition on. And that's how you can get a good, clean experience for speech recognition using Kinect. Because it's Kinect, because there's millions of devices sold, then this is also giving to the speech community and audio processing community a really nice de facto standard microphone array. So a really good benefit from side effect benefit for the community there. Over to Arnold to bring this together a little bit more.
Yeah, so you know, what did all this let us do, right? So all this technology, you know, we've talked about a few of these things already. You know, we can now watch, track, and render people. We have experiences that people are showing here and that I'm going to show you in a few minutes, where we're recognizing faces and we're tracking facial expressions of individuals and people. With the depth camera, we're recognizing voice through speech recognition. But what else can we do? What are the other experiences that we can either do today, and I'll show you, or stuff that's coming soon? Well, we can do background removal. We can take users and with the camera, effectively do what Hollywood green screening does, removing the background and presenting just the user segmented separately. I'll show that in an experience in a minute. We can do other types of skeletal tracking. So we're all very familiar with the standing skeletal tracking, and Stewart got into a little bit of the technology to do that. You know, and the magic behind that, which involves arbitrarily sized height, weight users walking into scenes with, being recognized, no calibration posed, and being tracked skeletally. Took a lot of specific training in different homes, lighting conditions, and with different people. Tracking other things, seated people, people lying down, I heard at the conference today, is something that doesn't work. People sitting in big, cushy sofas, doing hand or finger tracking. All of these things, again, they all require effectively the same magic, which is we need to do the work to collect the data, do the segmentation, do the machine learning algorithms that allow us to do the skeletal tracking in these different types of environments, in these different types of positional things. We know how to do it, and we're doing it. And it'll be coming more and more of those scenarios over time. We can do things like head tracking and have experiences that leverage that. One of the cool things I'll show you in a minute that we can also do, and that we showed in the initial Kinect vision, was doing object creation, taking physical objects and scanning them and putting them into the digital world. And of course, the other experiences that are coming are being created by folks like you, because we haven't envisioned all the experiences that can be created with this technology. I'll let Stewart, again, talk a little bit about how you enable that through the SDK.
Thank you. So what Arnold's highlighting there is this is how Microsoft Research and Xbox collaborated together to help these experiences for the consumer in an Xbox, in an entertainment scenario, for gaming and beyond. But we also recognize that this technology has a much wider potential, and you guys did too. About just over a year ago, August 2010, I started my conversations to help get this technology out to the wider community. I described my role, Microsoft Research Connections, as a bridging role between Microsoft Research and researchers and academia. And so my primary audience was for professors and grad students and how to get this SDK. But we also recognized quickly that, that if we can get this out to an even wider audiences, to Arnold's point, the potential here is just enormous in creativity. We need to be all working on this technology together. And so we from an early stage, thought about how we could get this out. That took a long time. Microsoft is a very large corporation. There's a lot of people that need to be involved in discussions. We worked as hard as we could, but we couldn't get it landed in time for the commercial retail release of the Xbox experience in November 2010. So I was still busy working with others, not least a famous alum of CMU. We worked together in trying to get this thing out, but it wasn't available, the SDK, for PCs at the time of retail launch. We kept going. We needed a few more conversations. We did finally get to that point, though. By February 21, not only did we have an announcement from people like me, a sort of a modest individual in the bowels of research, as a sort of like a hacker release, or for my professors and grad students, we actually got the president of Xbox, the interactive entertainment business, Don Matrick, and the top, essentially the CTO of Microsoft, the chief technology officer and strategy officer, Craig Mundy, essentially my boss's 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 boss. Craig and Don bought into this idea from an early stage, and they made a joint announcement. Xbox, together with Microsoft Research, together, they announced in February that the company would release this SDK, and it would be available in spring, infamously. Infamously, because I spent a lot of 2 a.m. and 3 a.m. and sometimes all-nighters, along with a number of my colleagues, trying to make this happen. And we've been working hard ever since. And we got there. We reached it. June 16th, it was still spring. Anybody questions this? It was still spring. I was reading a blog, I think it was Carl Makulis' a blog last night, doing some retrospective about some of the history here, and I was interested. Oh, there was real skepticism. You didn't believe us that we were going to release this in spring? We were committed. We lost a lot of sleep in meeting spring, but we made it. And June 16th, the SDK was launched in beta, and it's still in beta. But I'll have a little bit more to say about that in a second. So it is for non-commercial use at the moment, but we also announced at that time that a commercial release would be on the way. Don't get worried if anybody's nervous about the commercial release. I'll explain a little bit more about that in a second. But primarily today, it's for folks like you. It's for researchers, for academics, for enthusiasts, and for artists. It's a free download, etc. You're familiar. You know where to go and get it. If you haven't tried it, please check it out. The Kinect for Windows SDK beta that's available today gears both unmanaged and managed APIs. That means you can work in C++ or you can work in C# and Visual Basic. We still think that C# you can get a lot more done, a lot more quickly, but if you're hardcore and you like C++, it's there. It also works in some engines. Do you want to say a little bit more about that?
Yeah, sure. We have folks here and folks at the ETC and in other places using Unity. I saw a couple of talks today working in Sketch and some other development environments as well. So it's very friendly with a lot of less hardcore development environments, might be the way to phrase this. It just works. Yeah.
So there are also samples and documentations, over 100 pages of documentation, and something you may not have picked up on here because we sort of gloss over this ourselves in Microsoft, but this was Microsoft Research doing this in partnership with Xbox, but we were doing it on behalf of Xbox. And the reason for that is that Xbox was staffing up, building up the commercial product team. To start a product in Microsoft is a non-trivial thing. We're very serious about our products. And you need to build up a solid team. You cherry pick the best people to get involved in that team. You need the management, you need administration, and so on. So as Xbox were preparing the product development team, Microsoft Research had stepped up to temporarily deliver this non-commercial SDK. So for us to go the extra mile and produce some product quality samples and documentation was a stretch for us. But it's not just a Microsoft Research experimental release. It's not just something that we would put out alongside a research paper. We actually went the extra mile to get as near as we could to product quality, what Microsoft as a company thinks of as product quality. It does assume some strong programming experience, some programming experience. But I have to say, even though I put this kind of text in, I'm just amazed how quickly people get started with this thing. We've even seen people at the launch of the SDK. Josh Blake mentioned he was part of the 24-hour coding marathon we organized. Thank you, Josh, and anybody else here that participated. That was a crazy night. We saw people that hadn't even programmed on Windows there come through our 24-hour hackathon, and they came up with some really nice applications. So even people who hadn't programmed on Windows before get started with this thing in 24 hours with no sleep. What's in the SDK? I think you're all familiar, but what I want to highlight, not the small words here, but the large points are it's raw data, raw sensor streams, as well as the skeleton. We don't just sort of just get to the skeleton. That's what Xbox needed. Xbox needs less the raw data because the whole graphics pipeline is to get to the point where I can understand gestures. But for the SDK, for programmers on a PC, we give you that raw data, the raw sensor streams from the RGB camera and the depth camera. We give you the skeletal tracking, of course, as well. So you're getting the skeletal tracking quality that's on the Xbox today. This is full product quality, millions of users that we've generalized over these amazing number of training sets. And it's tracking what Xbox is refining over the coming months and years. So we've got a small lag at the moment, but as it gets to commercial product quality, you'll see parity start to emerge. It may always lag a little, but the SDK it's essentially there's one SDK. It's the XDK that runs on the Xbox, and we're as near as damn it to what runs on the PC. We also have those advanced audio capabilities, so as well as just getting the raw audio, you get things like that echo cancellation, you get things like that noise suppression, you get beamforming because you've got a microphone array there. It's easy to install. This is not one of our behemoth gigabyte installs where you've got a sort of half an hour to wait while the thing installs. It installs quickly. We try to make the experience relatively straightforward. Yes, there are some dependencies today. This will get better. We're only going to make it better. So install experience is really important to us. It was good. It was easy to install for a Microsoft Research product. It's designed for non-commercial purposes. A commercial version is expected, nay, planned for later. I know the people on the team, they exist. It is Windows 7 only. You know, we couldn't test on all of the different versions of Windows, and frankly, we are trying to look forward with this thing, not look back. Futures, we advertise this talk as looking both retrospectively, current, and also in the future. Let me say a few more words about the commercial SDK. It is coming soon. The non-commercial support will continue. It's not going to be suddenly we're going to switch out the lights, or you guys are going to be left with the old commercial, the non-commercial SDK, and we're going to move on while we talk to sort of a bunch of Fortune 500 companies. That is true. We are going to look at Fortune 500 companies and hopefully fulfill their needs as well as this community here. But this is an additional thing. So we at the moment can't meet the needs of our Fortune 500 partners and entrepreneurs. I know there's a number of entrepreneurs in the room. We will have a commercial SDK which will start to fulfill hopefully everybody's needs, both people that want to do this from a business point of view, as well as those who want to do it from a hobbyist, artist, research, academic and teaching point of view. There's one SDK, it's not going to be two, we're not going to fork the thing, and it's essentially the code that runs on the Xbox today. We actually made a late decision during the spring that did add a few more weeks, got us closer to June than perhaps we would have liked, where we decided to, rather than kind of reinvent the wheel and take some Microsoft Research code that had eventually found its way to Xbox, it is a port. We did the port from the Xbox during that early spring timeframe. As well as the commercial SDK, in a product group, with a proper product group, not Microsoft Research, alongside Arnold, we're also pursuing the research too, and you're seeing this. I know a number of you are tracking the research that Microsoft Research is doing, and of course there's what the academic researchers are doing, as well as a few other industry researchers. Our main channel, because we're like a giant computer science department, is research publications, academic publications at the conferences. Because it's computer science, the journals are not so important today. We tend to publish in conferences. So you've seen things already, not least just in the past 24 hours, I think. There's a new video or the paper for Holodesk. So we're doing both applications like Holodesk, but also underlying technologies, the platform technologies. Kinect Fusion is what underlies a Holodesk. Kinect Fusion got mentioned a number of times over the conference, a really neat scanning system. I can show a few videos about that if you've not seen it. Let me do that now. So you can go to YouTube just as easily as me, but here's the Holodesk if you've not seen it. This is showing a little virtual experience like a holodeck, but on a desk. Hopefully we're going to get a holodeck one day. Hopefully you recognize the Star Trek reference. Where, yeah, there's a few Trekkies, certainly in Microsoft. I hope there's a few Trekkies here. This kind of experience where it's a virtual environment where you can do interaction with virtual objects as a physical human being. There's a number of ways to extend this scenario. We go into it as you watch through the whole video. You can imagine this being used in a telepresence type scenario, for example. And this is an example of what I think of as an application. It looks generic. Of course it's generic. It's research. Microsoft Research is looking more for the evolution of technologies that product groups like Xbox can develop into real user experiences. We tend to be generic applications, abstract applications. Kinect is a key technology in this. We do face tracking. Arnold spoke to this, that face tracking is already coming to Kinect. It's not currently in the SDK today. And if you haven't, there's the Kinect. If you haven't seen the whole video, I recommend it. It's at the Kinect Fusion part of the YouTube. Let me head over to Kinect Fusion. If you haven't seen Kinect Fusion, this is an extremely cool video. It caused quite a stir at SIGGRAPH because this really was yet another breakthrough in the way that Kinect yes, you'd seen some Kinect-like technologies, and for thousands of dollars you could do Kinect-like things. Until Xbox, though, it wasn't available at the price point that it is today. Kinect Fusion is a similar breakthrough that we think that here we're bringing 3G object tracking, essentially a type of SLAM. We are bringing in real time the ability to scan a physical space and build that 3D model in the computer. And it's quite a phenomenal experience to see this live. It did take quite a stir. So again, I'm just going to give you a taste of that. You should check out the full-length video if you haven't seen it. Let me pause that. So that's just a little taste of the types of research that we're doing. Some of those were done collaboratively with universities. Again, some of this work is done in Cambridge in the UK, but there are other parts of Microsoft Research where we're doing Kinect research all around the world. We're as interested in this technology as you are, frankly. Back to Arnold.
So I want to switch gears now real quick and talk about something called Kinect Fun Labs. I found it interesting yesterday that there was kind of an informal poll where the audience was asked how many people own Kinects. And about 85% of the room raised their hand. And then they asked how many of the room own Xboxes. And only about 15 or 20% of the room raised their hand. And yeah, that's okay. I mean, you know, I'd like you to all run out to Best Buy and go buy an Xbox, but you know, if you're not a gamer, you know, fine. Why own an Xbox? Well, here's why I would say you might want to think about it, or certainly pay more attention to it. I think this community is a really cool community, and you're into sharing ideas and experiences and seeing what the state-of-the-art experiences are. Well, there's been about 12 million Kinects sold. And in my wildest thoughts, I have no idea, actually, statistically, exactly how many of those are people who own Xboxes and people who are like everyone here, or the 60% of you here that don't own an Xbox but own a Kinect. But let's make up a crazy number. Let's say 2 million. And this is a made-up number, right? I have no idea what the real number is. But let's say 2 million of them were bought without Xboxes. That means there are 10 million Kinects hooked up to Xboxes. It seems reasonable, right? And those 10 million Kinects hooked up to Xboxes have a whole bunch of people in Microsoft and people developing for the Xbox, building experiences for those consumers. So it's getting experiences on those devices. That's a huge, huge audience of people that can run cool experiences. So what are those cool experiences? Well, at Microsoft, we wanted to expose those 10 million people to cool experiences, because most of those people don't know how to hook up their Kinect to their PC and download a driver this and an application from here. They just want to have this easy, consumer-friendly experiences. So we developed this program called Kinect Fun Labs. How many people here have heard about Kinect Fun Labs? So assuming about half of the people are lazy and didn't raise their hand, certainly there's a large percentage of you that don't know what Kinect Fun Labs is. So, let me show you. Kinect Fun Labs was an initiative we announced at E3 in May. And it was a way to bring kind of hackish experiences to consumers. And being a commercial release, we of course, I got it. Yeah. No, I can use one of these little trackball things. We did a nice professional style video. Just watch this.
Welcome to Kinect Fun Labs. We're hard at work innovating some of the most fun and futuristic advancements ever. Over here, we have people pushing the boundaries of the latest Kinect technology. It's a whirlwind of progress that's inspiring a new level of entertainment. You see, The secret lies in Kinect's advanced capturing power that recognizes every single movement you make. It allows us to transform every cutting-edge breakthrough with the most exciting and imaginative experiences. Experiences that were never before thought possible. Over here, we're observing a normal family as they enjoy some of the latest Kinect experiences. Using a bobblehead, Dad scans his face and body, allowing Kinect's revolutionary people scanner to create a custom Dad bobblehead. Easy, Dad. No need to beat yourself up. In Sparkler, Mom uses Kinect's advanced finger tracking technology to draw herself some beautiful 3D wings. And with googly eyes, Sonny Boy scans his ball, bringing it to life with a whole new personality. Now he can make it move and dance however he likes. All of this puts you on the front lines of the Kinect revolution. But the amazing thing is, none of this is happening in the future. Kinect Fun Labs is live now. Holy moly! Visit the Kinect Hub on Xbox Live and try it today.
So other than giving our friend Christopher Lloyd some obviously badly needed work, that video to me is really interesting. And it's really interesting because he showed a whole bunch of experiences as he was walking around this futuristic lab. They're all real. None of them are fake. They're all actual shipping things. And they showed a whole bunch of uses of Kinect that we frankly envisioned when we launched Kinect a year ago, and when we showed the first vision of it several years earlier, or a year and a half earlier, but hadn't yet shipped and deployed in experiences. And I'll show them individually and talk about them. Some of them use skeletal tracking, some of them use depth map data as well. So some of them do their own machine learning algorithms for different types of tracking, like finger tracking. So let me just go into some of those and talk about them a little bit real quick and show some of these. I think you'll find these, or I hope you'll find these interesting. The first one I'm going to show is an application called Sparkler, and that was the one where the really creepy Christopher Lloyd drew the fairy wings on himself and on herself or whatever. But there's a couple of things in here I want you to watch and take note of, and I'll comment as it goes too to point these out. But it actually is going to show two things that aren't traditional skeletal tracking. The first thing it's going to do is it's going to show this background removal I talked about, where it takes a picture of an individual and then just does basically a mask around the body and then inserts a new background behind the person. The second thing it does is it does this finger tracking, and the finger tracking it does is very simple when the fingers are up versus closed, an open hand versus a closed hand. The open hand indicates the draw, the sparklers. So let me fire those up, and I'll point out both of these experiences when they're shown in the video. And I'll turn the volume on this down a little so I can comment on it. This video I actually got off of YouTube. It was an independent person demoing it. So this one actually wasn't produced by Microsoft. So this is him actually running the product. And what he's doing is the first thing he does is he creates a fun pose. And the Kinect takes a static picture of this. What it's going to do with this static picture is it actually, then it tells him to create a background. In this case, he's putting himself into the background. And what it does is it's going to take that background image of him going like this, and it remove the body on the top, and almost put it like, you can think of it as a layer in like a Photoshop app. So it's a two-layered image, and that's how it gets that perspective of rotation. Now what he's going to do is he's going to start drawing in 3 dimensions by tracing that body, and it's using the Z coordinate of the finger to determine the depth of the field. You can see how he drew that lasso around himself. He happens to be drawing what we call the Emperor Palpatine pose, which is a very popular way to demo this product, where you're, Emperor Palpatining yourself with the Force in a way. But you can see now as he rotates his head, you get that it is 3D, in that the background and the foreground are in separate depth layers, and then the sparkle trace is 3D around those 2 layers. So it's pretty cool. It's showing 2 things again: the finger tracking technology. It's of course showing skeletal tracking and using all 3 X, Y, and Z coordinates, and it's showing this background removal, which is actually a really cool capability of the depth camera that a number of the Kinect Fun Labs experiences are doing that are beyond just simple skeletal tracking. The other thing he's showing here is, as part of all the Kinect Fun Labs experiences, because these are shipped to consumers, we add a lot of nice consumer-friendly features. Like in this case, he took a still shot or a video and he shared it on the web via Facebook or so forth, to be able to share that video or that creation with other users. So that's a pretty cool example of the background removal, the finger tracking. Another good example that I like to show is this application called Googly Eyes. Now on this one, Christopher Lloyd, as the little kid in this case, the really hip kid, right? Who he took a basketball and held it up in front of Kinect. The way the experience works is, and I'll just run this. Actually, let me pause it. I just want to preclude it a little more. He takes an image of an object, any object, from the front and from the back. And what Kinect does is it uses the RGB camera and the depth camera, and it creates on the fly a mesh, an object, a mesh, and it textures that mesh. And then based on the rough shape of the object, we apply one of a series of default skeletons to it. And then we allow the end user to animate it with Kinect. So you can scan an object, it creates a 3D object in the experience, and then you animate that object. I'll just let you watch the video. The video in this case, again, it's not produced by us. I just got it off of YouTube. But they use a power drill. So this is kind of funny, and take note of how it's animated at the end. There's a prize, again, because this is consumer products. There's a lot of polish in these things, and there's a little song that plays. There's a prize if somebody can guess who the singer is in the song. So he's going to scan, in this case, the 2 sides of his power drill. Did one side. Now the algorithm actually works even better if you do more than 2 sides, but in a consumer experience, because this was going to these 10 million users, we decided for patience purposes, two sides was sufficient. He's going to create his googly eye.
Put you on stuff, put you on a small rock, now the small...
So here's our power drill. In this case, we put googly eyes on it, hence the name of the application. That's why I love that little stuffed Kinect sensor. I need to get one of those. You can see that it's not perfect, right? The hand showed through because he was holding the object. So, but it's pretty good, and it does a little show. And then he's going to create a skit where he animates it. Or no, right now he's changing the eyes, so you can move the eyes around. When you record a skit, then you can share the skit with your friend. But you'll notice that as it animates and bends over, it's 3D. This is not just a sprite. This is a fully, rigged mesh rendered with a skin shader, and you know it's bending and moving as the skeleton is animated, and it's pretty cool. And now in the lower right, you'll see he's going to record a little skit of himself doing something. You can see he bends and turns and twists and does different things. I'll stop this one. So that's pretty cool. That's object scanning and creation. Pretty cool experience. This next one I like to show, I'm going to show you because this one largely uses skeletal. It's about, so it shows that not all the experiences in Fun Labs have to be like the most hardcore high-tech research. And in fact, this one I would think would be something akin to, you know, that I might see out of some of the folks here in some of the application environments you're using. This one's called Airband, and all it is, from an experience point of view, is you lay down a background track, and then when you're standing there like this, you're neutral. I'm going to step out here. Because it's a skeleton, different height people, the guitar will appear at the right location relative to their hands. The keyboard height will appear, in his case, way up here, but if a short... I played this with my daughter, who's 7, and she'll stand next to me. We'll both do the keyboards. The keyboards will be down here for her and up here for me, because it's using the skeletal position to render the instrument. So very simple experience, audio, playing with a musical instruments played, and then just render based on the skeletal position an instrument on top, and it's a super fun, super engaging experience. The final one I'm going to show you is something called Avatar Kinect. Avatar Kinect is in the Christopher Lloyd video. That one was also shown in the Christopher Lloyd video. Avatar Kinect was when he was looking in a mirror, and there was an avatar of him, and it was reacting to his facial expressions. Avatar Kinect uses some of that technology. This video was produced by us, so it's a little bit more corporate.
Bring it on. 5 minutes to kick off. Let's hear your predictions. Go.
So this is using the Xbox avatars, which are pretty common in terms of a look and feel and a fidelity of the avatars.
With Avatar Kinect, users can hang out with up to 7 friends in 24 creatively themed stages, from talk show and late-night comedy sets to tailgate and performance stage, and capture animated videos to share with friends online. Invite friends to a tailgate party for the homecoming game and debate the odds.
You can think of this product as basically like a group chat room where the representation of the chat room on the screen are everyone in the chat room's avatars. But the avatars are not just avataring to your emotions, but they're reacting. It's doing facial tracking, and the mouth and eyes and eyebrow movements are all based on what you're doing in the room, or what you're doing to the camera. So if you're talking and you're doing different facial expressions, the avatar is doing, speaking as you in your voice, but its mouth and other facial expressions to the degree that the Xbox avatar rendering has facial representations of those attributes, shows those to the other users in the screen. And again, the purpose of Fun Labs is to just show these different experiences. There's obviously lots of experiences that can use object scanning, facial tracking, background removal, and in fact there's another half dozen Fun Labs gadgets that use different pieces of these technologies in different ways to show this stuff off. Let me switch back to the deck and we'll wrap it up. So that's Kinect Fun Labs. The I guess I'll close on Fun Labs just by talking about the fact that one of our goals with Fun Labs is to bring experiences to this 10 million consumer base that do interesting things with Kinect. And we also know that we're not going to create all those experiences. So I would highly encourage people, if they have things that they would like or they think are interesting Fun Labs gadgets or of that fidelity of an experience, to come and talk to me, because we are extremely interested in working with communities such as yourselves in bringing those experiences to market on the Xbox to those consumers and exposing them to those large consumer bases. I'll hand it back to Stewart and let him wrap things up on the SDK.
Thank you, Arnold. So that's really speaking to the community that we're building around the Xbox. Any artists in the room that want to get to those 12 million, speak to Arnold. For those of us that are looking on the PC side of things, the SDK beta has its own community efforts. Because it's non-commercial at the moment, this looks a little bit more as an enthusiast and hobbyist and academic type community building, but the commercial SDK will flesh this out further. So on Coding for Fun, Microsoft has a Channel 9 as part of our developer outreach, where we interact with the developer community around the world. Both commercial and non-commercial developers. We have a special Kinect area, and there's a project gallery on here. There are nearly 100 projects now that have almost all full source code, and you can think of this as, we ship a couple of samples in the SDK, they get full walkthroughs and so on, but here's the other 100 samples that exist for the SDK today. And there's just a plethora of diversity here around the various examples. You'll be familiar with some, but others you won't. So if you need any inspiration, it's a tough crowd, right? You guys are the inspiration. If you need further inspiration, though, check this out. There's 100 different projects on this site. We also have forums, and the forums are linked from our home site on researchmicrosoft.com today, but as we transition to the commercial SDK, I'm sure it will land somewhere else on microsoft.com or even in the Xbox tree. But for the moment, in research, researchmicrosoft.com/Kinect SDK, you can get to our forums. You can also get to the project gallery from there. Bottom right-hand corner, it says watch on this screenshot, but today, if you go to the site, you'll see it says project gallery. The forums is a place for not only for you to get product support, even though it's a non-commercial SDK, we have paid people that are involved in the product team that are developers, and they're working on those forum stuff in those forums. There are thousands of posts today. Yes, it's a lot to trawl through, but you can ask questions on there, but you can also give feedback. What do you think about the SDK? What do you think about the direction of the SDK? This is a beta. We release betas so that we can get feedback from the community as to how we can make this better for everybody. So send your feedback to those forums. This is a social experience. Xbox inspired us all with their interest in bringing social experiences to gaming. Microsoft Research is proud to be part of that with Xbox. We've been partners from the beginning through getting this technology out to you folks and the consumers. You are part of the community too. This is just a wonderful experience to be at this conference. Thank you for sharing your demos. I'm holding back from showing more demos because there's just so many great demos all day. Thank you again for your time and listening to us. I'm sure we're available for a little bit of time for questions. Thank you.
We definitely have time for a couple questions. Down there in front in the blue shirt.
Developing a bunch of software for children on the autistic spectrum really pricked my interest when you said you've got 12 million Kinect users out there. But I'm trying to make something that's as open source as possible and can go to as many different platforms as possible. Can I get myself out to Kinect and still have an open source code base?
Joel, is your question how could it be easier to author for the Xbox perhaps as well?
Your question is how can you develop on an open source code base to allow cross-platform execution? Well, certainly, you're doing that today. So there's, we're not against that for any I'll use your word, moral reasons, and by all means do that. You know, our systems are not open source. We're a business, and we fund development through selling software and hardware. But and the Microsoft Kinect SDK is not open source, but it is you know, available in commercial and non-commercial forms in compiled form, and allow you to give your product away or sell it, presumably, in the way that you see fit. I don't know all the terms of the final release SDK, but we're not preventing you from doing what you're doing today. In any case, with the systems and libraries you're using, they'll have a different set of capabilities than ours will, and that's just a matter of course.
I guess the question was, can I release something for free on your Kinect marketplace that could then get into everyone's homes if they wanted it?
Are you familiar with what the policies are going to be? Well, which marketplace? Yeah. The Kinect.
Xbox. I want to get it. I want it to be on Xbox. You know, or if there was some way to get it out there as a free product for people on the autistic spectrum to use as a therapeutic tool.
On Kinect Fun Labs, or some other Xbox-oriented distribution.
Yeah, some way to get it into the sitting room.
Yeah, that's certainly something I think would be reasonable to discuss with us. We don't have a formal program to do that. The Xbox is a managed ecosystem of software for you know, very, very legitimate business reasons. But you know, we're not draconian either. You know, and it's something worth discussing. The other thing I should mention is that most of the Fun Labs experiences are free. We don't charge for those. At least we don't charge consumers for them. A lot of them are sponsored. A sponsorship model where we get an advertiser to sponsor it for either a month or a one-time fee, and that's how we fund the development of these little gadgets. They're lightweight experiences. If the funding of that and the development of that is done by you, because you want to do this, and you know, you want to be able to distribute it, I think that's something we'd be extremely open-minded to discussing, because the model is largely a non-charge consumer model. The question then becomes, how do we fund the creation of them? And funding the creation of them is either pay somebody to do it or find somebody who just wants to do it. And if you just want to do it, awesome. Yeah. You had a second part of the question that Golan added? What? Yeah, so let me talk about that briefly. So the Xbox, you know, it requires this thing called an XDK. And the XDK also requires, as part of the XDK, you get the, you know, all the software necessary to develop for the Xbox. But you also get something called, or have access to something called an Xbox Development Kit. So kind of the double meaning of the XDK. And that's a piece of hardware that's special that allows you to develop for and compile to. It requires commercial agreements and NDAs and such in place with Microsoft to do. That's true for all the consoles. That's not unique to us, for long-standing business reasons. One of the things that we're doing and working on and that we're starting to see is the availability of more common development frameworks on the Xbox is starting to happen. So, for example, many Xbox experiences that I showed in those videos are built in Unreal. So if you built an Unreal application, in theory, it ports right over. One of them in particular, the air guitar, was written in Unity. So Unity now runs on the Xbox. So we're currently working on, it's not done, it's not released, ways to sample applications to make sure that if you're writing something in Unity, that it easily ports, that it can just go back and forth between the two. That's something we aspire to be able to do. So I don't know that the answer to this question is make everyone have XDKs and Xbox development kits available, but I think the ability to say, here's how you develop on the PC that allows you to just very easily, when the time is right, get things running on the Xbox is the model we're pursuing more.
In the interest of time I'd like to end the session there.
Okay.
That's fine.
Yeah.
If there are a few more questions,
Yeah, these guys will be available.
We'll hang out.
I'm available.
And I wanted to just say thank you so much, Stewart and Arnold.
Thank you.